All right, today we're going to solve systems using elimination. This is our third day in a row solving system, third different method. To be honest, probably my pick of the three, but we'll see how it goes. Here's how it works. Steps, and you should have done this before in Algebra 1. You can multiply one or both equations by some number called a constant to get coefficients that only differ in sign. Then you can add the equations together, like combine like terms. Let that eliminate. That's what's called elimination. One of the variables, and then you solve for the variable that's left. After you get that variable, you substitute that number into step 2, one of the equations that you started with, and get the other one. So still, those are kind of complicated words for a process that's not that complicated. So let's just look at a couple examples here. So it says solve by elimination, which is what you're going to say all day today. What I need to do is I need to get one of my variables to go away, to eliminate, and I'm going to multiply one of my equations or both of them by something to make it go away. So what I'm going to do here is I'm going to multiply the whole entire top equation by -2, because that's going to give me a -6x in my top equation, and I have a positive 6x in my second one, which means they're going to eliminate each other. So I have -6x. You've got to multiply everything by -2, plus 14y is -20. The second equation, I have 6x minus 8y equals 8. And I'm going to combine those equations together. When I do that, those cancel. So I have 6y is -12. If I divide by 6, I get y is -2. And that's awesome, and that's great. But I still have to find the x. Now, this is one place where substitution is a tad bit better. You can pick either equation you want to plug your y back into to get your x. That's your choice. I'm going to pick the top one. So I'm going to say 3x. And if I do -7 times -2, that's positive 14 equals 10. I'm going to move that 14 over and then divide by 3, and I get -4/3. So my solution would be -4/3, -2. And you can check it. Obviously, you can plug it in the second one to see if it works. It will. So that's the process. Not too bad at all. Let's do one more like this one, and then we will show you one special case. I like this case right here because 3, if I'm looking at these two equations, one thing I notice is this 3 doesn't go into 4, 6 doesn't go into 7. And when that's the case, I'm going to have to multiply both equations to find something that they both go into. And it's your choice. You can, 7 and 6 go into 42. You can do that one. 3 and 4 both go into 12. I'm going to choose that one because it's smaller. Seems like it'd be a little bit easier to to do that. So I'm going to multiply the top equation by +4, because that's going to give me a +12, and I'm going to multiply the bottom equation by +3, which is going to give me a -12. I want to have opposites. So when I do that up here, I get +12x minus 24y equals 36. Come down here, multiply everything by 3, you get a -12x, which is what I wanted, plus 21y and -48. And then I'm going to combine those equations. That's out of here. It gives me a -3y. And over here, I get a -12. If I divide by -3, I get y is 4. And again, once you get your first variable, you're going to plug it back in either one of those you want to get your other one. I'm going with the first one only because the number is a little smaller. So I'm going to say 3x. And if I do 6 times 4, that's 24 equals 9. Move that 24 over, gives me 33. Divided by 3, that's 11. So my solution is going to be 11, 4. All right, hopefully that makes some sense to you. I'm going to show you one special case like I did yesterday and see what we can figure out. All right, one special case here, and then we're done. This one is the same type of situation because if I'm looking, 4 doesn't go into 14, 10 doesn't go into 35, so I'm going to have to multiply both equations again. And again, sure pick which one you pick. I'm going to choose the 4 and the 14 just because they're smaller, and 4 and 14 both go into 28. 4 goes in there 7 times, so I'm going to multiply the top equation by 7. Give me 28x minus 70y and 56. The bottom equation, 14 goes into 28 2 times. It's already negative, so I'm going to do -28 minus 70. Plus 70 equals -56, and that's looking really weird to me because what's going to happen here is everything, if I add those, I get 0. If I add those, I get 0. If I add those, I get 0. So I get 0 equals 0. And you have to ask yourself, does 0 equal 0? And it does. It's true, which means there's infinite solutions. There's infinite amount of solutions, not all reals, but infinite. And what we called that the other day was we called it consistent and dependent. when that happened. Hopefully, remember those words a little bit. All right, that's really all there is today. So tomorrow will be our third day in a row in systems, and we'll do everything by elimination. And hopefully, that's my favorite method, and I think it'll be yours by the time we're done. At least I hope it is. But anyway, see you tomorrow. Look forward to it. Goodbye.